You know that feeling, right? You're sitting at a red light, first in line, and you're just staring at a completely empty intersection. You wonder, why am I even waiting? It's maddening. Well, what if we could teach our traffic lights to, think for themselves? Today, we're going to dive into how exactly that's possible with something called reinforcement learning. I mean, really think about that for a second. What if, instead of being stuck on some dumb, rigid timer, a traffic light could actually see the traffic building up and make a smart call right then and there? That's the game-changing idea we're going to unpack. All right, so first up, let's talk about the problem. And it's one we all know way, way too well. It's that daily grind, that daily frustration of sitting and waiting for absolutely no good reason. Here's the thing. Most traffic lights out there are basically just kitchen timers. Green for 30 seconds, red for 45, and then do it all over again. They have zero idea if there's a huge traffic jam on one side or if the other road's been totally empty for 5 minutes. They're rigid, they're dumb, and that's where all the inefficiency comes from. But there's a kind of AI that is just perfectly built for this mess. It's called reinforcement learning, and its whole philosophy is about learning by doing, basically by trial and error. Okay, so let's break down the lingo, because it's actually pretty simple. You've got an agent, that's our AI traffic controller. It lives and works in an environment, that's the intersection, and its one and only goal in life is to take actions that get it the biggest possible reward. That's it. The absolute best way to picture this is learning to ride a bike. Nobody hands you a manual, right? You just get on and try. When you're balancing and moving forward, that's positive feedback. Your brain goes, hey, this is good. And when you wobble and crash, that's some very clear negative feedback. Bit by bit, mistake by mistake, you figure it out. And this all happens in a continuous cycle called a learning loop. The agent is constantly going through these 4 steps. First, it looks around and observes the current state. How many cars are waiting? Then it takes an action. I'll keep the light green. After that, it gets a reward. Did that help or hurt? And finally, it sees the new state and starts the loop all over again, getting just a tiny bit smarter every single time. Now, imagine that loop running not once or twice, but thousands, even millions of times in a simulation. Eventually, after all that practice, the agent develops its own masterpiece, a policy. You can think of this as its ultimate playbook. It's a strategy guide that tells it the absolute best move to make in any situation, all to get that maximum reward. Now, it's really important to get this. This way of learning makes reinforcement learning a whole different beast compared to other types of AI you've probably heard about. See, most AI is supervised learning. You basically feed it a giant database with all the right answers already in it. It's like giving a student the textbook and the answer key to memorize. Reinforcement learning? Totally different. It's like putting that student in a science lab with no instructions. They have to poke things, try stuff out, and learn from what happens. They discover the answers for themselves. And that right there is what makes it so perfect for a problem like traffic. There's no answer key for every possible traffic jam, and RL Agent doesn't need one. All it needs is that reward signal, that simple good job or bad job feedback. It lets the AI discover strategies we might never have even thought of, all on its own. Okay, so let's take all this theory and apply it directly to our streets. A great way to think about it is like a video game. The AI is playing the traffic control game, and when it wins, we all win because traffic just flows smoothly. So, in our game, who's the main player? That's the agent. It's the AI brain living inside the traffic signal, and its only mission is to make things better. And what's the game board? Well, that's the environment, the intersection itself, every single car pulling up, every queue getting longer, every turn. Now, before making a move, the player has to know what's happening on the board, right? That's the state. It's a live snapshot of all the important data. How long are the lines? How packed are the lanes? How long have people been waiting? Okay, so based on that state, the agent gets to pick a move. These are its actions. It can choose things like, let's extend this green light for another 5 seconds. Or, nope, time to switch and let the other direction go. And here is the most crucial part of the whole game. How does it know if it made a good move? That's the reward. If its action makes wait times go down and reduces congestion, boom, positive reward points. But if it causes a backup, oof, negative reward. That simple feedback is the only thing guiding it toward becoming a master player. So, what's the point of all this? What's the actual real-world payoff?
Well, when you let an AI learn the traffic game this way, the impact on our cities is, well, it's huge.
I mean, when you put them side by side, the difference is just night and day. On one side, you have the old school rigid timers that just fall apart the second traffic gets unpredictable. And on the other, you've got this adaptive, efficient system that actually learns from the real world and is always trying to do better.
And this isn't just a cool idea. This stuff actually works. Studies and real world tests have shown that these RL systems can cut down average vehicle wait times by more than 20%. 20%. Think about what that means for your daily commute, for fuel savings, for just less stress.
So look, if you take away just one thing today, let it be this. This isn't about programming a smarter traffic light once and walking away. It's about creating a system that teaches itself, a system that adapts to rush hour, to a ball game letting out, to construction, and it just keeps getting better and better, all on its own.
And that kind of leaves us with this really cool final thought. If we can teach something as simple as a traffic light to learn, what's next? What other parts of our cities could start thinking for themselves? It really makes you wonder what a truly smart, self-optimizing city could look like. Something to think about. Thanks for watching.